This is a story about the relationship between wingspan and height for some data that we took in Physics 141. So this is all of the data that you entered. Notice it doesn't all look the same. There's some intervals, there's some holes, there are units. So I cleaned the data up. Whenever you have form data, it's always entered in a variety of ways, and that's normal. So here's the data, and it's all cleaned up. So I am going to download this data and work with it in Microsoft Excel. So under the File menu, there's Download As. I'm going to download it as a Microsoft Excel file. And then I'm going to open it up in Microsoft Excel. So here's the data in Microsoft Excel. So remember, there are these two tabs. We're going to work with the cleaned data. It's always good to keep a record of the originals because maybe you make a mistake when you're cleaning. So I want to know what the relationship is between wingspan and height. And so I'm going to look at that relationship with a graph. Now, when you graph things, there's an output variable, or a y, and there's an input variable, or an x. I think height should predict what your wingspan is. So that means height will be x, and wingspan will be y. There's nothing special about that. I'm just making a choice right now. So to make a graph, I'm going to highlight all of the wingspan numbers, and then I'm going to insert a scatter graph. Now, these are all wingspan data points, and this is nothing yet because I haven't included the height. So I'm going to click with my right button, the Properties button, and I'm going to select Data, and I'm going to edit the data series that I have. And for the X values, or the input, I'm going to select height. So if I click on the top cell, and then I do Shift Control down, I select all of the elements. And now, it looks like there might be a relationship. It's not a very good graph yet because nothing's labeled. So under the, it's either Design or Format. It's under Design. They have this quick layout thing, and this button isn't bad. So the horizontal axis is height in inches. The vertical axis, or the output variable, is wingspan in inches. Notice you always want to write down the units so that you know what you're talking about. And then, let's see, I probably want to zoom in on the data. So to zoom in on the data, you can click like this number right here and set it to be, I don't know, like 50. And you can click on this number right here, and you can set it to be 50. All right, so now we have a good picture of what the data is. So here are all the wingspan values. Here are all the height values. So this person right here, whoever they are, their wingspan is smaller than average. And the reason why I say that is because this line is one way of expressing what the average of the relationship is. So the line goes through all the points kind of as good as it can. And so if you're below the line, then for your height, your wingspan is, slightly less than average. This person, comparatively, has a slightly larger wingspan than his average. So this person might actually be good at an athletic game where you have to reach, like the sit and reach test in gym class or basketball. I don't know. I'm just making this up. Now, it's always nice to know what the equation is because then you can make predictions about the future. So under here, we can click Format. And so this is just all the trendline options. I want to look at what the equation is. So I click that box. Now I've got this equation, which is awfully small. I can make it bigger. Okay, so we're almost done. We've got a mathematical relationship between these two variables. We've got a graph. It looks like the line goes through the data pretty well. And I've even been able to tell some stories about shorter arms than average and longer arms than average. Or you could say for the same, for this arm length, these people are short. And for this arm length of 65 inches, this person is exceptionally tall. On average, right? I've never met any of these people, so I don't know if that's true. I'm just looking at the data and saying that. The last thing I'll add is that this is not a math model. It's just a fit line. Y isn't real, and X isn't real. And so to illustrate that, oh, not that article. To illustrate that, I wanted to show you this printout. So this is our equation, but in Physics 141, we're always trying to describe the real world. And so we don't write Y, we write wingspan in inches, because that's what we're actually plotting as a Y. In the same way, we don't plot X, we plot height in inches. So notice my math model has wingspan for Y and height for X. And height has a unit, inches, and wingspan has a unit, inches. The other thing you'll notice is that instead of writing 4.7, nothing, I'm writing 4.7 inches of wingspan, because this 4.7 is a real object. And this 0.94, so you could say that for every inch of height, you have 0.94 inches of wingspan. This slope means something physical. So if we ever talk about a math model in this class, remember that it should never include Y. It should never include X. It should always include real things that we can measure.